F3, Unit 5, Parallelogram proofs. Okay, so we're going to be proving that things are parallelograms. And there are 5 different ways of proving that a quadrilateral is a parallelogram. Remember, a quadrilateral has 4 sides. So one is both pairs of opposite sides are parallel. Another is one pair of opposite sides are both parallel and congruent. Another is both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. Or the diagonals bisect each other. If you can prove any of these any of these things, then you can prove that a quadrilateral is a parallelogram. All right. So use the diagram to the right to prove the following theorem. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So what we are going to be given here is that the diagonals bisect each other. The diagonals are AC and BD. And we're going to prove that ABCD is a parallelogram. All right, so we're filling in the blanks. Our first statement is always what we are given. So AC and BD bisect each other. And our reason is always given. M is the midpoint. So if they bisect each other, then M is the midpoint of AC and M is the midpoint of BD. Since that's the midpoint, that makes AM congruent to CM and BM congruent to DM. That is the definition of a midpoint. So AM and CM, DM and BM. Angle AMB is congruent to angle CMB. That is because those are vertical angles. So what other angles can we prove are congruent because they're vertical angles? That would be this one and this one. So angle AMD and angle CMB. So now triangle AMB is congruent to triangle CMB. And this is by side angle side. So what other two triangles are congruent by side angle side? AMB and CMB. So now I'm going to use CPCTC, which remember is corresponding parts of congruent triangles are congruent, to prove that this is a parallelogram. So looking at what's going on later, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we're using that both pairs of opposite sides are congruent. So using CPCTC, we're going to say AB is congruent to BC, and we're going to use AB is congruent to CD. By CPCTC, because these triangles are congruent, then those sides also have to be congruent. And that makes this a parallelogram because both pairs of opposite Given that ABCD is a parallelogram and M and N are midpoints of AB and DC, prove that AMCN is a parallelogram. So prove this middle piece is a parallelogram. So the first thing is that we are given that ABCD is a parallelogram and that M and N are midpoints. The reason there is given. AB is parallel to BC, and so AM is parallel to NC. This is the definition of a parallelogram. So we have AB is parallel to DC. So AM is parallel to NC. AB is congruent to DC, or AB is equal to DC. This is by the definition of parallelogram because opposite sides are congruent. The first part there would have been opposite sides parallel. So half AB equals half DC. This is just the multiplication property. If AB equals DC, if you multiply both of them by the same thing, then it's still equal. AM is going to be half of AB and NC is half of DC. That is because it tells you that it's a midpoint. Midpoint cuts it into two halves or two congruent pieces. So this is by definition of midpoint. AM equals NC, or AM is congruent to NC. So now we've got this guy congruent to this guy. And we had that they were parallel to one another. So this is because if these two things are equal and these are equal to that, this is substitution. We just plug those in. And so the last thing is AMCN is a parallelogram. And that is because one pair of opposite sides is both parallel and congruent. So the next one, FGHJ is a parallelogram and FK equals HL. So this guy and this guy are congruent, and the whole outer thing is a parallelogram. Prove KGLJ is a parallelogram. So FGHJ is a parallelogram, that's given. JG and FH bisect each other. So this one and this one bisect each other. That's by the definition of a parallelogram. Or diagonals bisect each other of a parallelogram. O is the midpoint of JG and FH. That would be the definition of bisector. FO equals OH. That would be the definition of a midpoint because we said that O is a midpoint. So FO and OH have to be equal. So that would be the definition of a midpoint. FO equals FK plus KO. So this is the sum of the parts equals the whole. So that would mean OH is going to equal OL plus LH. So if FO equals OH, then FK plus KO must equal OL plus LH. This is by substitution. So what we did was we knew that these two things were congruent. We said that these two things were congruent to these other two things and plugged those in for that. Fk is congruent or is equal to HL. That is given to us. So that means that KO equals OL, and that is by the additive property. If you add something to two congruent things and they're still equal, then these two things must be equal. That's the addition property. So we have KO and OL are congruent, are equal. O is the midpoint of KL. That is by the definition of a midpoint because it cuts it into two congruent pieces. And the definition of segment bisector would be that JG bisects KL. By the definition of segment bisector. So that means that KGLJ is a parallelogram, and that is because the diagonals bisect each other. So we already knew that JG bisected each other, so that JG, so this guy here and this guy here, were congruent as well. So because the diagonals bisect each other. Just two more examples. Given that ABCD is a parallelogram, DE is congruent to FB, so this is congruent, and this is congruent, and the whole outer thing is parallelogram. We're going to prove two things. One, triangle DEA is congruent to triangle BFC, so this triangle and this triangle are congruent, and the angle 1 is congruent to angle 2. So parallelogram is given to us. AD is congruent to CB, and that is because opposite sides of a parallelogram are congruent, or by the definition of parallelogram. Angle D is congruent to angle B, because opposite angles of a parallelogram are congruent. DE is congruent to FB, that's given to us. So now we can say that these triangles are congruent like we were supposed to. Triangle DEA is congruent to triangle BFC by side angle side. And then we can say that angle 1 is congruent to angle 2 by CPCTC. Corresponding parts of congruent triangles are congruent. One more. Given that ABCD is parallelogram, prove triangle AEB is congruent to triangle CED. So it's a parallelogram, that makes AB congruent to CD because opposite sides of a parallelogram are congruent. AB is parallel to CD. Opposite sides of a parallelogram are parallel. Angle CAB, so this angle, is congruent to angle ACD. Those are alternate interior angles. If you extend this line, that would be your transversal. These will be your parallel lines. So those are alternate interior angles. Angle AEB right here, is congruent to angle CED. And those are vertical angles. So now we have triangle AEB is congruent to triangle CED by angle side.